Hello, chemistry students. Here is your Chapter 7, Section 2 notes, the molar mass of a substance, kind of day one. There will be 2 days that sort of have the same title here, although they will be different. So, Section 7.2 is called mole mass and mole volume relationships. And we're going to start by talking about the molar mass of a substance. The atomic mass of an element, which is the mass of a single atom, is expressed in atomic mass units, AMUs. So remember this is the number from the periodic table. In AMUs. And on that ChemQuest number 39, the intro to moles, you did some work with this, okay? Remember that atomic mass is a relative mass based on the mass of carbon-12. So back in Chapter 5, we talked about where the masses of these elements came from. And remember, it was a weighted average of all of the naturally occurring isotopes of an element. And because the mass of an actual atom is a tiny little number, and chemists in general don't like to deal with tiny little numbers, instead, they set up a relative scale where they're comparing every element to the mass of carbon-12. These atomic mass numbers are not whole numbers. These are not whole numbers on the periodic table because they are that weighted average masses of the isotopes of each element. So the last thing we can say is that the atomic mass of an element comes just in a minute here. Okay. So again, we're just talking here about what those numbers are on your periodic table that you learned back in Chapter 5, about the fact that this was an average atomic mass. It's taking into account all the different isotopes of that element, and it's comparing all the elements to carbon-12. So what is molar mass? Molar mass is the mass of a mole of an element is its molar mass. So the mass of a mole of an element is its molar mass. Basically, this is the atomic mass of an element expressed in grams is the mass of a mole of the element. So again, you did that on that ChemQuest where you looked at the mass of a single atom in grams, and then you figured out how many of those atoms it would take to equal the atomic mass of the element in grams. And you discovered that always that was the same number of particles, that Avogadro's number of 6.022 times 10 to the 23rd. So the molar mass of any element contains 1 mole, or 6.022 times 10 to the 23rd atoms of that element. That's what the molar mass is. Because of that, the molar mass of any two elements must contain the same number of atoms. So all that's saying here is, okay, the molar mass is the mass of the element from the periodic table. So if we have 12.011 grams of carbon, we have 1 mole of carbon. And 1 mole of carbon is 6.022 times 10 to the 23rd atoms. Well, if I have 14.007 grams of nitrogen, so the mass from the periodic table, if I have 14.007 grams of nitrogen, that means I have 1 mole of nitrogen, which means I have 6.022 times 10 to the 23rd atoms. So again, this is just saying the molar mass of any two elements must contain the same number of atoms, because that's definition. Molar mass always contains 1 mole, and 1 mole is always 6.022 times 10 to the 23rd atoms. Another way to define molar mass is to say that molar mass is the amount of substance that contains the same number of representative particles as the number of atoms in 12.0 grams of carbon 12. Again, all this is saying 12.0, that's the mass from the periodic table for carbon. So if I have 12 grams of it, that means I have 1 mole of it. If I have 1 mole, that means I have 6.022 times 10 to the 23rd atoms. Okay, and that's what molar mass is. So a molar mass is the amount of substance that contains the same number of representative particles as the number of atoms in 12.0 grams of carbon 12. So, a real-world connection to this, because sometimes this is something that's difficult for people to grasp. This idea that 1.0079 grams of hydrogen, which is the number from the periodic table, the atomic mass, is 1 mole of hydrogen atoms, is 6.022 times 10 to the 23rd hydrogen atoms. Yet, for sulfur, it's 32.00 or 0.065 grams of sulfur to have 1 mole of sulfur. How can I have such a difference of mass required to equal a mole? So the real world connection for this is to think about eggs, okay? You can buy small, medium, and large eggs the size of the eggs doesn't affect how many eggs are in 1 dozen. Similarly, the size of the representative particle, in our case we've been talking about elements, so those would be atoms, okay? So similarly, the size of the representative particle doesn't affect how many are in 1 mole. Okay, so think about eggs, right? Think about you go to the grocery store and you buy a dozen eggs. Probably you're going to buy large eggs. And there's a certain weight to those dozen eggs, correct? But it's still a dozen eggs. So now let's kind of make this extreme. Let's imagine we're somewhere where we can buy ostrich eggs, right? You know ostrich eggs are a lot bigger than chicken eggs. But I'm still going to buy my ostrich eggs by the dozen. I still have a dozen eggs. Is the mass of those dozen ostrich eggs the same or different than the mass of the dozen chicken eggs? I think you all know that the mass of the ostrich eggs is a lot different. It's going to be a lot larger. It's the same thing with the atoms of the periodic table. A mole is always 6.02 times 10 to the 23rd atoms. If those atoms are really small, like in hydrogen, and they're not very massive, I can have 6.022 times 10 to the 23rd atoms of hydrogen, and I'm only going to have 1.0079 grams of hydrogen. If I contrast that with xenon, an individual atom has a mass of 131.29 grams. Okay? So, if I have, or AMUs, so if I have 6.022 times 10 to the 23rd atoms of xenon, I'm going to have a mass of 131.29 grams of xenon. 130 times the mass of hydrogen. That's because a xenon atom is a whole lot bigger than a hydrogen atom. So you have to keep in mind that as we talk about a mole here, the important part about talking about a mole is that a mole is always 6.022 times 10 to the 23rd. You can also think about this with like balls, right? If I have a dozen ping pong balls versus a dozen basketballs, right? The size that they take up, volume-wise, and their mass are different. And I still have a dozen. The same thing is true when I talk about having 1 mole of some substance. I always am going to have 6.022 times 10 to the 23rd. How much mass that is going to depend upon the size of the atom or the substance. If it's something that's large and massive, it's going to take a large mass to get 6.022 times 10 to the 23rd. If that substance is really tiny, then it's not going to take very much mass. So let's take a look at a problem here. We want to figure out the molar mass of sulfur, carbon, and iron. So you should have 3 different molar masses. Now remember, to get the molar mass, you're going to just look at your periodic table. You're going to use that average atomic mass, and you're going to express it in grams per mole. So the molar mass of sulfur, when you look at your periodic table, is about 32.1 grams of sulfur per 1 mole of sulfur. So again, 32.1 comes from my periodic table, my atomic mass for sulfur. For carbon, that number is 12.011 grams of carbon for 1 mole of carbon. And lastly, for iron, it's 55.845 grams of iron for 1 mole of iron. So this gives me a new conversion factor for your chemistry toolkit. Remember, you used a scrap sheet of paper or an index card to make yourself a chemistry toolkit. And so this new tool that we're adding here has a name. Its name is molar mass. And it's going to be some number of grams of substance over 1 mole of substance. And it has to be the same substance, right? Again, up here, iron and iron, carbon, carbon, sulfur, sulfur, has to be the same substance. Where does this number come from? This is my number from my periodic table. Okay, so again, if you can find your chemistry toolkit that you started, you can pause this YouTube video for a moment and add this new tool to your toolkit. So now you should have 4 tools on your toolkit. This is the first tool that it has a special name. So, to find the mass of a mole of a compound, right? Because what we were talking about just now was an element. You must know the formula of the compound. So again, this kind of goes back to that idea that you have to be able to write the chemical formula for ionic and molecular compounds. For example, if I want to talk about sulfur trioxide, and I want to know what its molar mass is. I have to first write the formula. So sulfur trioxide, though it's 2 nonmetals, so 2 nonmetals means it's a molecular compound, and my prefixes become subscripts. So my formula is going to be SO3. Now, I'm going to show work for how you get this. But again, this is one time when you wouldn't have to. So in sulfur trioxide, I have 1 sulfur atom and I have 3 oxygens. Next, I need the masses of these elements from the periodic table. So the mass of sulfur on my periodic table is 32.065. For oxygen, it's 15.999. So remember, again, you did these the other day on your ChemQuest. You started to do this. And then I add these 2 masses together. And so I get 80.062. And because this is molar mass, this is going to be units of grams per mole. So that means that if I have 6.022 times 10 to the 23rd molecules of sulfur trioxide, I'm going to have 80.062 grams of sulfur trioxide. So to kind of summarize that, right? To calculate the molar mass of a compound, find the number of grams of each element in 1 mole of the compound. Then add the masses of the elements in the compound. So a problem for you to try really quickly. Figure out the molar mass of water and of glucose. In case you don't know the formula for glucose, it's C6H12O6. And again, for molar mass, you are not required to show work. You can just use your calculator. So water's formula is H2O. So again, I'm going to show work so that people who don't understand and who are struggling can see how to do this, but you don't have to. So water has 2 hydrogens and 1 oxygen. The mass of hydrogen is 1.0079. That's from my periodic table. Oxygen is 15.999. I'm going to add these two together, and I get 18.0148 grams per mole because it's molar mass. All right, here's your glucose. Yes, you don't have any homework tonight, so here's glucose. Again, it's C6H12O6. So I have carbon, hydrogen, and oxygen. I have 6 carbons. I have 12 hydrogens. I have 6 oxygens. Using my periodic table, the mass for carbon is 12.011. Hydrogen is 1.0079. And oxygen is 15.999. So I have 72.066. I have 12.0948. And I have 95.994. Then I'm going to add those 3 numbers together. And I get 180.1548. And again, it's molar mass, so it's grams per mole. So that brings us to a good spot to stop for today. Okay. Make sure you've added that tool to your toolkit. And again, you have no homework. Talk to you tomorrow.